Hi, welcome back. This is Lab 9 about the Shack Cube Interferometer. As per usual, I'll go over a little bit of the theory first, get into the experimental setup, and then some of the results. To start off, this diagram shows the use of a Shack Cube Interferometer. The important aspects to note are the spatial filter, spherical reference surface attached to the cube, and the test arm with the spherical optic that's being tested. A fantastic aspect about the design of this interferometer is the placement of the reference surface. Optical aberrations are often characterized as the deviation from a perfect spherical wavefront. The Shack Cube design creates that spherical wavefront and then compares it to the test wavefront. This allows us to read the interferogram like a simple contour map. Our lab setup was basically identical to the diagram shown earlier. We used two optics to test. One was a reference mirror with a long focal length, and the other was a test mirror with a short focal length. The interferograms for the long focal length mirror had a decent contrast to them. As I mentioned earlier, reading interferograms from the Shack Cube is like reading a contour map. Hence, when we tilt the optic, we get linear fringes, and when we add defocus, we get these circular fringes. Unsurprisingly, adding the two has a result of moving the circular fringes to the left or right or up and down. The interferograms for the short focal length test surface had a much lower contrast and it was a lot harder to see the fringes. But you can just barely make out some of them. The defocus still had circular fringes, tilt had linear fringes, and then the combination of both of those resulted in a bullseye that was moved a little to the left. This was a short lab today, so I'm going to end it here. I added a picture of a cat because why not? He's cute. Thanks again for watching, and I'll see you next week.